First thing I want to mention is a definition. Continuity or continuous. If a function is continuous, that means that its graph can be drawn without picking up your pencil. It's not the most formal definition, but it gets the idea across. If I can draw the whole graph without picking up my pencil, that would be a continuous function. So if I had something like this, that's continuous. I just drew that whole thing without picking up my pencil. If I have something like this, is that continuous? No, because I had to pick up my pencil to do that. When I am talking about things being continuous, you are going to give me intervals where it's continuous, and you will use those x values. Just like when we were talking about increasing and decreasing, you gave me an interval using x. When is the only time you will use y in an interval? If I ask you for the range. The range is the only time we're using y. Everything else we're talking about x. And the reason is, if it's a function, when I say x equals 4, that's a single spot on your graph. There is no other spot. But if I say y equals 4, could there be multiple spots on the graph where y was 4? Yeah. So that's why we have to use the x for those things. Okay. So first we're just going to look at some graphs and decide where they are continuous. So if I'm looking at A, this is super hard to tell, and I apologize because I scaled it down and printed it. There is an open circle in this graph right here. So it's supposed to be like an upside down parabola with an open circle. So if I wanted to know where it was continuous, what would you tell me? You're giving me the x, and it's continuous everywhere except when our x is 0. Remember, in that interval notation, parentheses mean not equal to, brackets are equal to. If we look at B, can I draw that whole thing without picking up my pencil? So what's my domain? Okay. C. Where is that graph continuous? You're giving me the x values, so coming from negative infinity up until the point when x is 2, and then again after 2. D, where is this one continuous? Negative infinity to positive infinity. It's continuous everywhere. Do we understand what I mean by continuous? Okay. So now we're going to get into our common functions. So the first one, the identity function. Everybody should be able to graph this one pretty easily. F of x is the same thing as what? Y. So if I say y equals x, what's that a graph of? A line. Y-intercept is 0. Slope is so up 1 over 1. Alright. So then you just draw your line. If I asked you some questions, what's the domain? Infinity to positive infinity. What is the range? This graph, it's always continuous, isn't it? Is it increasing, decreasing, or constant? Increasing from negative infinity to infinity. Okay. I didn't write all those down, but could you guys, if I asked you where is it continuous or where is it increasing, can you answer that? Alright, so identity. Y equals x. Second one we see a lot is the square function. F of x or y equals x squared. What does that look like? Parabola. My general rule on anything we graph, I am going to tell you at a minimum 3 exact points. How would I get exact points? Plug it in. Can we make a t-chart? Absolutely. So give me a number to plug in. All right, let's try 0, 1, 2. What's 0 squared? 1 squared. Okay, I'm just putting them into this equation. So 2 squared is 4. So we have 0, 0, 1, 1, 2, 4. Is that enough? What else do I need? Okay, let's try negative 1, negative 2. Negative 1 squared is 1. Negative 2 squared. All right, could we do more if we wanted to? Absolutely. If you did 3 squared, that's 9. Negative 3 squared is 9. You can always do more. So now I have a pretty good idea of my graph. So we have our nice parabola. What is the domain of that? What is the range? Good. And 0 would get a bracket because it does equal 0. If I asked you increasing, decreasing, constant, this graph starts out decreasing from negative infinity to 0, and then it is increasing 0 to infinity. All right. Are we okay with that one? Okay, cube function. F of x equals x cubed. So what should we do? Make a t-chart. Every time I ask you to graph these, I'm going to expect points on them. You don't have to write out your t-chart for me every time. I mean, we're going to graph x squared enough that we know. If you just want to think through it in your head, if you get to that point, you can. That's fine with me. But I should be able to clearly see your dots on the graph. If you need to write out the t-chart to know your points, then do it. Okay? It doesn't hurt us to write it out. So we should always make sure we're putting in some negatives, some positives, and 0. So I'm going to do -2, -1, 0, 1, 2. What is -2 to the third power? -1 to the third power. 0 to the third. 1 to the third. 2 to the third. All right, so I plot these. -2, -1, -1, 0, 0, 1, 1, 2, 8. Can you tell what your graph looks like? Like that chair. You guys remember seeing this one before? Good. If I asked, what's your domain? What's the range?
Girls golf is dismissed at this time. Girls golf is dismissed at this time.
Girls, if you will watch the video to finish the notes, we are not going to finish today, so it's one assignment for the next 2 days. So we'll finish tomorrow, but we'll be able to start this. All right. This graph is continuous everywhere, negative infinity to infinity. It is increasing, negative infinity to infinity. No decreasing or constant. All right. Let's look at another one, the square root. Do you guys remember the square root graph? That's cube root. in, can I put in negatives? No, because that would give me imaginary numbers and we're not graphing imaginary. So what is the smallest number I can put in? And the square root of 0 is? Square root of 1 is? If I'm trying to graph it, I'd like some nice points. What else might we put in? Square root of 4 would be? Square root of 9? Okay, let's plot that. And we don't extend it both ways because remember we said we can't put in the negatives. What is the domain of this? Because it's a closed circle, 0 is a bracket. Range, same thing. Compared to positive infinity. All right, just a couple more here. Any questions so far on these? The cube root function. Can I put in negatives? Yes. What would be some nice numbers to put in? I heard 0, I heard -8, and +8. What else? 1 and -1. Let's try it. Cube root of 0. Cube root of -8. Cube root of +8. Cube root of 1. And cube root of -1. Now, if you struggle with that, can you use a calculator to evaluate those? Absolutely. No, you're not allowed to have a graphing calculator to just draw the graph, but you have a regular one. So if you can't do those cube roots in your head or you're questioning yourself, put them in. That's no big deal. 0, 0. -8, 2. So it's like our sideways chair. And took our cube function and flipped it on its side. What's our domain? And the range? Is this one increasing, decreasing, or constant? It's increasing. Not a lot, but it is still going up. So it is increasing the whole time. All right, you guys try one. I want you to figure out the absolute value graph with exact points. So the absolute value of 0 is 0. Remember, absolute value just makes things positive. Absolute value of 1 is 1, 2, 2, 3, 3. You can keep going as long as you want. -1, 1, -2, 2, -3, 3. Only thing I want to mention here, make sure your absolute values, that's a V, so that's pointed. Your parabolas are curved, that's like a U. So make sure as you get to graphing these that I can tell the difference. I always have a couple people that are just not as neat and I can't tell that a parabola is curved and that an absolute value is not. So make sure you're clear on that. All right, those are the common ones that as we go in the next couple sections, we're going to start doing transformations. So those are the ones that we will be using. The last thing that I want to cover today, I want to do maybe 1 or 2 piecewise examples, and then I'm going to stop and we will finish this section tomorrow. So a piecewise function is just any function where you have multiple rules. And so you have different rules for different parts of the domain. So you might have 2 pieces, you could have 3, 4, 5, 6, there's really no maximum. So it's saying for different x values, you do different things. If you want to graph these, what do we have to do? We we do our T-chart. What I ask is that we do a separate T-chart for each piece. Okay, that usually helps people a little bit. So for my first piece, I want to figure out what that looks like. I need at least 3 points, but there is one number that I have to plug in. I have to put in the 1. Angela. I have to put in 1. How come? But it doesn't have an equal to. So why am I putting in 1? Okay, it will be an open circle because that's our starting point. Can you give me the first number that's less than 1? 0. But what about 0.9 or 0.99 or 0.999? That's why we have to plug in the 1. Okay, we can't just leave a gap. So we'll put in the 1, but because it wasn't equal to, that is an open circle. So the first x value you have to put in is whatever is listed there. And then that tells me what to pick for my other values. I only want things that are less than 1. So less than 1 we said was 0. Give me one more. All right. And I'm plugging those into this rule. So 2 times 1 plus 4. If we put in a 0, 2 times 0 plus 4. We put in a 1, 2 times negative 1 plus 4. So on my graph, 1, 6 is an open circle. Then I have 0, 4. It's only the first circle that's open, so these others are closed circles. When I go to draw this line, keep in mind that open circle was my starting point, so I don't have arrows going both directions. We were only traveling the less thing. Now the second piece. What's the first x value we have to plug in? 1. Will this one be open? No, because it had an equal to. And then what kind of numbers do I need to put in after that? Greater. So maybe a 2 and 3. So 4 minus 1. 4 minus 2. 4 minus 3. And I'm doing the 4 minus because that's the rule for that piece. Okay, so if I plot 1, 3 was a closed circle. 2, 2, 3, 1. And it was only for x is greater than 1, so we only extend it to the right. When you get to the end, I want you to do something. Look at your graph. It was originally f of x equals, so that told me it was a function. If it's a function, then what has to be true about our graph? Passes the vertical line test. That will help you catch your mistakes. If you have 2 open circles, or sorry, 2 closed circles, or if a line went the wrong way, if you check to make sure it passes the vertical line test, you will correct those mistakes. Let's do domain and range. This graph's a little more interesting than the other ones. What would be the domain? This one's coming from negative infinity and stops at 1, but the next one picks up at 1 and goes forever. So the domain is negative infinity to positive infinity. What is the range of this graph? Start down here at negative infinity. The blue one stops, but the red keeps going until we get to 6. What would I have to put on my 6? Parentheses, because it was an open circle. If I asked, where is this graph continuous? Negative infinity to 1 with a parenthesis, union, bracket 1 to there in the middle when we jump from one piece to the next. If I ask for it, when is it increasing? -1. Where is it decreasing? 1 to infinity. So I can ask lots of questions about these graphs after we get them. All right. I think I'm going to go ahead and stop here. Tomorrow we will do several more piecewise examples, and we're also going to talk about the greatest integer function. So we'll finish this notes handout tomorrow. I have a handout for you. You're not ready to do all of it yet, so you could probably do the front side, but I wouldn't do the back yet until we do a few more piecewise examples. So how many T-charts do you need? What's the first number you plug in?
0.
Open or closed?
Closed.
Okay, and then okay. If we put in negative or 0, what do we get out?
-2.
We put in -1. The opposite of -1 would be +1 minus 2. If I put in -2, opposite of -2 is 2 minus 2. If I put in 3, opposite of 3 is 3 minus 2. So 0, -2, -1, -1, -2, 0, -3, 1. How do I know which way to extend this line? Our starting point was here. We are going from less than, so it extends this way. This one, what's the first value you plug in?
0.
And then, okay, if I put in a 0, we get, what kind of circle would this be? If we put in a 1, 1/2 minus 2. -3 put in 2, 1 minus 2, -1, if I put in 3 halves minus 2 is -1/2. What if you already have a closed circle there? You leave it closed. If you ever end up with an open and a closed circle at the same spot, you just leave it closed. Don't try to draw an open circle around it, okay? It's just a closed circle there. Then we have